The biological imperative, as we all know, is to pass on genes. Most species on Earth use sexual reproduction. Why do this? There has to be some fundamental biological evolutionary reason for sexual reproduction. This has been one of the major questions in biology for a very long time.
For 25 years, Robert Reinhoek has been returning to the remote hills of Sonora, Mexico, hoping to find clues to the enduring mystery: why sex? In this dry and forbidding landscape, he seeks those clues in the lives of fish.
To study the sexual process, which appears to be normal, predominant in most things, I study the diseases of sex, the pathologies of it. Little fish, in this case, that live in the Mexican deserts that have abandoned the sexual process. And the beauty of this is it's a natural experiment, because side by side in these same little puddles, we'll have sexual reproducers, we'll have asexual reproducers, all competing in these tiny little simple environments. I could try to study this in a massive environment like an African savanna, but I can't manage an African savanna. With my capabilities, I can manage a few small pools like this, and for 30 years I've been coming back to this part of Mexico to study what goes on in these pools. We got some. We did good. This is a good sample here. Look at how black these fish are. Wow. Look at the pigment on them.
Early on, Reinhoek discovered that 40% of the minnows in these pools were heavily infected with a parasite that causes black spot disease. The rest seemed relatively unaffected.
When we brought them back to the laboratory and started counting the spots, we noticed, well, my goodness, this is really neat. The asexual reproducers were taking much higher loads of parasites than the sexual reproducers on average. Why should they be more parasitized than the sexual reproducers? They were living right beside, because they're all being exposed to the same parasites in the water. There should be no fundamental reason for different parasite loads on these different kinds of animals, unless it had something fundamentally to do with being asexual as versus being sexual.
But what? The only thing to do was to keep walking and sampling and thinking. Finally, it hit him. He was looking at a real-world demonstration of the value of males, one suggested by an evolutionary theory called the Red Queen.
The Red Queen is an elegant idea. I think it's one of the great ideas since Darwin. And it goes back to a wonderful scientist, Lee Van Valen, who basically asked about, does evolution stop when things get perfectly well adapted to their environment? He said, of course not. Evolution is a race, and it's much like the race we saw in Alice and the Red Queen in Alice in Wonderland, where they were running just as fast as they can, and Alice says, isn't this curious? As fast as we run, nothing seems to change. We're staying in the same place. And the Red Queen says, yes, you have to run just as fast as you can to stay in the same place. You're living in a complex world, a world full of parasites, a world full of viruses and bacteria, predators, competitive species, all basically evolving too. And the moment any species stops evolving in response to these challenges and threats, it's doomed.
The cloned fish have stopped evolving. They're an easy target, especially for a short-lived, fast-evolving parasite. But the sexual fish are a moving target. Each is a new combination fashioned from its parent's genes.
So as far as the parasite is concerned, every individual in that sexual population is a unique and individual challenge, and that slows down the transmission of the parasite through the sexual part of the population.
Here was a solution to the mystery of sex. It's the best defense against rapidly evolving enemies. Or so it seemed, until a bad drought dried up the pools, killing the minnows and throwing everything into question. Eventually, the water returned, and so did the minnows, having slowly worked their way back up the hill from pool to pool. When Reinhoek checked the top pool, he made a disturbing discovery. Now the parasites were decimating the sexual fish, The clones were doing quite well, thank you.
This is absolutely contrary to anything we'd seen for many years previous to this. Now it was completely upside down. Something mysterious was going on. Now an opportunity, you see, to do some science. Nature had done an experiment for us. We had to find out what happened, what changed. We collected the fish. We can then examine them carefully, and what we found in this case is that the sexual species, in the process of recolonization, had lost its genetic variation. It had become inbred.
Testing revealed the sexual fish to be clone-like. They now resembled each other genetically. And since they outnumbered the true clones, they were being targeted by the parasites. As a final test, Vreinhoek conducted a simple experiment.
I went downstream with my bucket into a lower pool where the fish still had genetic variability, and I took some fish from there, put them in my bucket, hiked back up the mountain, and threw them in the pool where the fish had lost variation, and came back a year later just to see what happened. And it's just a wonderful result. This parasite load in the sexuals had dropped right down to the levels it used to be in the past. The asexuals now were taking the brunt of the parasite attacks. And when we examined those sexual fish, we found that we had, in fact, successfully transplanted genetic variation into that pool. And you see, that's precisely the point. That's what sex does. Sex generates variability among offspring. And when you take that away from a sexual reproducer by inbreeding them, or cloning them, you've lost the very benefit of sex. It's that generation of an immense amount of diversity. And that diversity of your offspring, it provides challenges to everything around it, challenges to the parasites, challenges to the viruses, challenges to your competitors. That's the beauty of the sexual process, is the variation and wonderful diversity it creates.
The lesson taught by Vreinhoek's little fish is that passing only half your genes to your kids is a price worth paying. Sex generates variation, which improves a species' chances of survival in a world dominated by relentless competition.